Hi, my name is Nick, and I am here to present the solution to problem E, first last. In this problem, Alice and Bob are playing a word game. From a word bank, Alice will choose some starting word. Players alternate choosing words. If the other player chose a word ending in some letter, the current player must choose a word starting with that letter. No word can be chosen more than once, and the first player to not have a valid move loses. Determine who wins if both players play optimally. In this problem, there are at most 1,000 words. Also, the number of letters that can possibly be at the beginning or end of a word is at most 3. So we'll start by reducing this to a graph theory problem. So assign each letter a vertex, and for a word that starts with one letter and ends with another, draw a directed edge going between those two vertices. Note that these two vertices may be the same, in which case this edge is a self-loop. So then we can do a reframing of this problem in graph theory terms, where one player chooses a starting vertex, and then each player gets to traverse an edge that hasn't been used, and the player loses if they end up at a node, and they have no other nodes to go to. So what we can do now is we can show that there are some edges that we can remove from the graph, which will not affect the final outcome. So, for example, if there are at least 2 self-loops for some vertex, we can show that the result is the same if we remove 2 of the self-loops. Finally, if there is a cycle of length 2, so you have an edge from U to V and an edge from V to U, you can also remove those 2 edges. So we repeatedly remove edges of this form, and then we can show that the reduced graph now has at most 3 self-loops and no cycles of length 2, so it only has cycles of length 3. Now, the graph is simple enough, pun potentially intended, that we can just memorize the winner for all of the possible graphs that result.